Hello everybody, System Chalk here with the 8th, well, okay, we'll say it's part 8 for the RoguelikeDev does the complete roguelike tutorial. Obviously there will be more than 8 videos in this series because I have found some sections take longer than others, and I suspect that some of the more recent videos will be more representative of the time that it takes rather than the others, for the simple reason that whenever I take a look at the sort of the slide bar on the right, it does seem to be that there's just a lot more text. And this, of course, makes sense, right? Because we're sort of past the part of sort of hello world or move an object on the screen. We're really sort of getting into the substance of what playing the game is like, giving the player the information that they need at the time. And then, of course, there is the whole question in terms of what my own understanding is. There's plenty of times where I've tried to do something or I've tried to do an extension, and that hasn't always worked out for me. So on that note, I was actually going to talk a little bit about one thing that puzzled me at the end of part 7. And so there's a couple things that I did. I do tend to find that there's a benefit, like it's neat to sort of have a document of real-time decisions and sort of learning at the time. But there is, at least I find, a tremendous value to, getting up and going for a walk or, having a cup of tea or something like that. And in this particular case here, that was really what helped out. So the problem that I had before, I've got some of the text in the game here, although I have already made a change. But when I played the game, I'd run through the dungeon and I would, I'd do my things and then my character dies. And anytime you tried to move the mouse after the character died, you would get this error here in input handlers. Runtime warning, this event's tile coordinates are uninitialized. You must pass this event to context convert event before you can read its tile attributes. And it gives the offending text here. Now, actually, this was an example. This was something I added here. I was wondering when it originally said uninitialized, maybe this was a case where you have like .x. So there's this convention, it's the duck typing convention in Python, right? Where if this thing is some version of none or null or whatever, then presumably this would return false, and it doesn't even bother checking in bounds. And, there might be a decent intuition behind that, but that's also not really respecting what the warning is saying, which is you must pass this event. So the original text was, in this case on line 61, in self game engine map in bounds, event tile X, event tile Y. Notice that the error moved up to line 60, and that's because I was looking at event tile X and event tile Y in the conditional at the top. It's actually probably better if I just bring the input handlers code up. So essentially, the error that was being encountered happened in this part, right? So it was happening on line 61, and sort of from the context of the warning that we were getting, we had event tile X and event tile Y. Although I suppose there is an interesting question in terms of in bounds. So I guess presumably checking in bounds would have done the conversion. Let's actually maybe just check that. I don't want to spend too much time on this, but I didn't really consider why there wasn't an error before. Okay, so it takes an X and Y and sees, okay, that's interesting. So for one reason or another, we could take event tile X and event tile Y, and that wasn't a problem. But as soon as we took those and used them as in this case, we used them as sort of inputs to a conjunction, right, an AND. It didn't like that. And definitely it didn't like that under self-engine mouse location, event tile X, event tile Y. So, we clearly saw that this worked in in the main game. We clearly saw that this worked when we implemented it inside of the tutorial. The only time that it didn't work was after the player died. And so, at that point, you're like, okay, well, what happens when the player dies? We have that in AI. And when you take a look at die, I thought maybe it's in fighter. Yeah, sorry, it is in fighter. Under die, the big thing here is it changes the event handler. So you're like, oh, okay, so that's interesting, right? And you may, once you start looking at this, it's like, well, if that's the case, why is it, worrying about something on line 61 inside of event handler? Why isn't it, worrying about something inside of game over handler? Well, game over handler hasn't, it doesn't have, or actually, I guess it does. Sorry, it does have handle events here. But the reason why it's moving up to the main class is that it doesn't have the EV mouse motion. So long story short, the offending line was the fact that under, let's take a main game event handler here. So we've got context convert event, and the tutorial is actually pretty clear that you need to add that. And this is the reason why I'm taking the time to talk about this, is I actually think this is kind of an interesting case where I feel like something may be a mistake, or there may be a subtlety that I'm not following here. I only just recently posted on the subreddit in terms of what my issue was, so it wouldn't be fair to say, oh, and I never got an answer to the question. No, because I did not get a 10-second answer to the question. So once we add it here, right, we've got, where was it? Context convert event, and it refers to, here we go. And uses context convert event to give event knowledge on the mouse position. It then dispatches that event, which is handled like normal, right? So that's why that winds up in sort of the parent class. And in this section here, right, you see it inside of handle events, inside of event handler. You see it inside of main game event handler. And quite notably, there is the game over event handler, and it changes the signature of handle events, but it does not actually descend into the code and adds context convert event. So what happens here is you've got an action self dispatch event, which eventually brings it back to, I think, EV mouse motion, and that's what prompts the warning. So I originally wanted to sort of say, okay, well, I was maybe just rushed in terms of my implementation. That's an easy mistake to make, especially because it doesn't crash the game. It just gives you a warning at a time when you would quit out of the game anyway. But that was the time when I took a look and I thought, well, okay, there might be something else going on here, because clearly there was a change already made to game over event handler. In fact, it puts the context inside of handle events, and it quite notably avoids adding that particular line. And then if you take a look at the code in the section here, incidentally, I do wonder, so it says at the top, I noticed that under the branches there's a 2021 version. Oh, but it only goes up to part 5. That's why that's why it isn't there. But I'm sorry, I should have actually gone in. So I wanted to see, okay, well, let's maybe make sure that I'm not completely losing it. But you'll actually notice that it doesn't have the context convert event here. So I tried running this on, I took that specific branch and put it into onto my machine, and I tried running it, and I got the same warning. So obviously there's a few different things that could happen here. A new version of TCOD, sometimes there'll be a version of Python that comes out and you start seeing certain warnings. I think we also talked about how there's a different version of NumPy, so NumPy 2. The one thing I'm reluctant to say is, as we've sort of noticed if you've gone through the whole series, there's a number of changes that I've wanted to make to the program, right? Like I was sort of seeing, it's like, okay, how can I use this pattern matching? This seems I think I've finally found, what this thing is intended to do. Let's see if I can add it inside of the program here. And in the end, that didn't really work. I eventually discovered the wisdom of just doing simple if and else if, and why that makes more sense for this project here than some of the other alternatives, at least based on my understanding. So pretty much any time that I've had sort of a dispute with the tutorial, not even dispute with the tutorial, but any time I've tried to do something different with the tutorial, very often what has happened is I have learned later on when implementing the next steps that it usually creates more problems for me, or that I'm sort of limited in terms of what I can do in terms of those alternatives. So I tend to revert them, or I tend to go back to the way that the tutorial is doing things. So with that in mind, if I run into something and then, my immediate answer is, oh, okay, well, that must be a bug. My actual inclination is to say, there is something that I'm misunderstanding here. And of course, that something that's misunderstanding could be that there is a change to TCOD over the time between when the tutorial was written and when I'm implementing this stuff. So the changes that have survived are very often the cases where I'll add, TCOD event keysim KP1 as opposed to the other way. And again, the ideal for me is to, hit a level of knowledge in terms of this project, even if it's just a question of, just sort of rote implementation of a solution that is recommended in the warnings. What I ideally like to do is get to that point where I say, okay, I am not seeing any warnings in this project. It is implemented in accordance with the wishes of the developers of the library and the tutorial. So in this case here, I've added something. The sort of summary out of all of this is that I've added one simple line to game over event handler. My justification for it is that it, well, one, gets rid of a warning, but on top of that, each other implementation of handle events does seem to use the convert event, and the warning gives a good reason as to why you would want to use convert event. And I am not sold that there is a meaningful difference between the game over event handler and the main game event handler that would change the behavior of the mouse over. Clearly there are differences. There is a reason why we remove the AI from the player and things like that. But when it comes down to specifically the mouse behavior, I am cautiously willing to say that this may be an example where, because it didn't sort of crash the game, this is something that should have been implemented, but for one reason or another wasn't inside of the tutorial. But again, I am doing this in 2004. This is an annual event in the RoguelikeDev subreddit. The likelihood of me discovering something that hasn't already been seen by someone else, particularly at my level of understanding, is pretty low. But for my own part, I guess the thing I would say right now is that if in the end I want to try and get to a point where I can justify as much as I can inside of this project, I feel comfortable doing this, and I could not justify removing this other than saying that this is in the tutorial right now. And so ultimately I've decided to put that in. And if that blows up in my face later, well, them's the breaks, right? All right, so I'll just give a quick example of what I was sort of showing. Okay, we've got an orc here. So if I mouse over, okay, we've got our orc. All is well. So just let him whack away at me for a bit. All right, splat, I'm dead. Try to use the movement keys. Those don't do anything. Move the mouse, notice there's no warning. And when I move over the orc, we've got it there. And if we move over the remains of the player, we've got it there. Everything seems to be working the way we want. The last thing we check is the escape button, and we exit the program without any warnings. So that is about as close as I'm ever going to get to saying this was a justified deviation from the tutorial. And, I hope maybe within a day or two, the fine and very long-suffering members of the RoguelikeDev community will maybe just verify, yeah, that should have been in there. And it's possible that in this week's material, there'll be mention of that. I try not to look ahead. There's something nice to be said about the spontaneity of doing the tutorial as part of a series, sharing that with people. And that does mean that my less than inspiring moments of ignorance, those shine through. But it does mean that there's that opportunity to just sort of see, all right, not everything is a straight line. Maybe a little bit more of a straight line because I'm implementing somebody else's stuff. But hopefully the active part of the learning is coming across. So, quick refactors. Once again, apologies to everyone reading this right now. After publishing the last two parts, there were once again a few refactors on code written in those parts. Like at the beginning of part 6, luckily the changes are much less extensive this time. So we will start by going into AI. So we will remove component-based component. It is appallingly hot today. Okay, so we're removing base component. Now we go on to message log. So we are removing iterable, it looks like. Oh no, sorry, we're adding iterable. After render, under message log. Okay, so we're adding wrap. Line and string split line. Oop. Yield wrap.wrap line width expand tabs true. Okay, does not like that parentheses for some reason. Oh, I see. Okay, so moving on, this is no longer a static method. This is a class method. Will that share what it is? Class method. A class method receives the class as an implicit first argument, just like an instance method receives the instance. To declare a class method, use the idiom class C, class method, def, CLS, argument. Okay, it can be called either on the class or on an instance. The instance is ignored except for its class. If a class method is called for a derived class, the derived class object is passed as the implied first argument. Class methods are different than C++ or Java static methods. If you want those, see the static method built in. So the read I get from that, right, the adding the class here, this is a little bit like, how we have self at the front of things. I think in this case here, this is saying is like the message log is the first argument here. I am slightly curious what that changes. So render the messages provided. The messages are rendered starting at the last message, working backwards. So we've got our offset. The tabbing is a complete catastrophe here. So we're changing this line. So we've got for line in reversed. Okay, so we're taking the class. Oh, I get it. Okay, yeah. So what we're doing here is we're using the wrap that we just defined. So wrap for the class. Tab that in. Yeah, so the rest of the tabbing in here is just us tidying things up. So if the y offset is less than 0, we don't have space to return messages. Okay, so a little weird there in terms of the spacing. I'm not quite sure what caused that, but I think I understand that change. So under game map, we are adding the property game map to return itself. So it looks like we're doing something in entity to make that. There's something in entity to make that useful, but I'm not 100% clear what this is doing yet. Okay, so under entity, what's the story here? Iterator, good lord. I wonder how many of those are sitting in the files. Because again, presumably, there might be a way to make it so that you like it doesn't move forward until you satisfy all of the types. But I think in this case here, it's just going to sort of yell at you and then work. So there could be a bunch of those. Oh, sorry, there was one other thing that I changed. There was I think it was supposed to be an optional, but I didn't actually say what the option was. So I know somewhere I added something like a optional entity or optional action or something like that. I do apologize. I forgot where I did that. Okay, anyways, let's carry on. So class entity. So in this case, we are now saying parent. And under the init, same thing, parent. Well, actually, this should be a little... okay. So there's going to be a side of me that says, well, what if we just did this? And yeah, that would be a bad idea. So I'm just going to say parent and basically just rely on the warnings. Okay, so we're good there. And then now we need to add another game map. Okay, property. So I'll confess, this is one of these things where I'm sort of like, I'm doing this and I have a broad understanding in terms of what this, like functionally, I sort of understand what this does, right? All that we're doing here is we're sort of doing this parent and we're adding some different, some different lines that will make sure that we're still getting the game map that we want. It's not quite clear to me yet in terms of why we're doing it this way. So, all right, so if has attribute parent, so this is still dealing with the fact that it may not be initialized. If oh, this is actually quite different. So okay, so possibly uninitialized if self parent is a game map, or specifically self game map. Self game map entity. Okay, actually that can So this makes sense now why that's there. Okay. Again, sort of a tenuous understanding in terms of what this is doing, but I'm at least sort of following the logic. I'm sort of hanging on by my fingernails, but okay, fighter parent. Okay, base component. So under type checking, we are from game map, import game map. Base component is now parent rather than entity. We are adding the game map property. And then we are changing engine to produce game map engine, no entity. Okay, on to fighter. So again, entity parent. I have a feeling it's a lot of these. So under the class, again, there is actually a side of me that wants to, well, let's actually take a minute here. This might be one where it might be appropriate to change that. So entity parent, entity parent, or entity parent. All of this. Okay, so this is one of these cases where when you take a look at all of the highlights, this is very clearly one where I'll want to change entity parent, except for type checking, but I can always redo that one. So that should... Okay, so that is all of the refactoring. Now, before I commit any of this, it would definitely be a good idea for me to... wondering why this says modified, but the others don't. All right, I won't question it for now. Let play. All right, so the generator object is not reversible. This was back in the message log. I forgot to add the list. So line list CLS wrap. Okay. Promising start. Okay, mousing over the orcs works. I'm going to slam into a wall before I... Okay, let's actually get rid of those jokers. This is also a chance for us to see... Okay, now that's interesting because I believe there should be 2 orcs here if I'm not mistaken. But we do have a player on top of it, so... I might try to take out 2 orcs on top of each other just to see if I can... Okay, that's promising. Okay, yep, so I thought there were 2 orcs and I was maybe missing, so let's just take a minute here. I want to make sure that I'm slamming into walls in all the relevant directions just to make sure that I'm not losing... I'm not overlooking any problems. And then the last thing that we do is perish in the dungeon to make sure, oh no, a troll. Okay, so we didn't crash when the troll got us. The mouse is moving around to try to move the character. And finally we hit escape. So everything's working the way that it's supposed to, and the no warnings, we could escape properly. So refactor should be good to go. Oop, I didn't mean to push, but that's fine. So I'm just going to take a second to tidy this up. Because I'm splitting the attention between the tutorial and VS Code on the same window, it does get a bit cramped here between in terms of all of the different tools. So, okay, so far our game has movement, dungeon exploring, combat, AI, and AI. Okay, we're stretching the meaning of intelligence and artificial intelligence to its limits, but bear with me here. Now it's time for another staple of the roguelike genre, items. Why would our rogue venture into the dungeons of doom if not for some sweet loot after all? In this part of the tutorial, we'll achieve a few things, a working inventory and a functioning healing potion. The next part will add more items that can be picked up, but for now, just the healing potion will suffice. For this part, we'll need 4 more colors. Let's start by getting those out of the way now. Open up color.py and add these colors. Okay, so invalid, impossible, and error. Again, I have no idea what color this will be until I look. And error. Finally, we'll change the welcome. Oh, health. Okay, simple enough. These will become useful shortly. There's another thing we can knock out right now that we'll use later, the ability for a fighter component to recover health, and the ability to take damage directly without the defense modifier. We won't use the damage function this chapter, but since the two functions are effectively opposites, we can get writing it over with now. Open up fighter.py to add these two functions. Okay, so I think we're just adding these at the bottom at this point. So we've got init HP setter die. So def heal self amount int returns an int. Self HP equals self max HP return 0. New HP value equals self dot HP plus amount. New HP value greater than self dot max HP. New HP value equals self dot max HP. Amount recovered equals new HP value minus self HP. Good Lord. Self.hp equals the new HP value. Turn. And then def take damage self amount int. It doesn't return anything. HP minus equals the amount. Okay, so quick little bit of logic. Like if you think of it, right, you'd sort of say, okay, well, you just heal yourself. You know, that's easy. Just, you know, make the HP go up by a certain value. But we've already established that there's a max HP. Now, this is a design decision, right? Some games will allow you to go past your limit. Quake is a really good example of that, where you have some health kits that will allow you to go up to your max value. And then you have others, or sort of shards, or other smaller amounts that will let you exceed it. And then there are also some games which will allow you to sort of overcharge your health, but at the on the condition that that amount goes down over time. So you can sort of give yourself this sort of supercharge. It encourages you to act very quickly because the bonus health that you're going to have is only temporary. So, and of course, all of these are potential solutions to either problems or ways that you might encourage the players to behave in a certain way that you want. So, for instance, we've talked a couple of times, and this is really just because, you know, if I'm completely honest with myself, this is probably the roguelike I'm most familiar with, Crypt of the Necrodancer. So I think Crypt of the Necrodancer, we'd said earlier that its origin seems to be sort of Ryan Clark saying, you know, I really like Rogue, but I don't like the fact that I can go off, have dinner, and nothing has happened in the dungeon until, you know, I've decided to make a move. What happens if instead of it being a fully turn-based game, what if we put a timer on the movement? And then sort of from there, it takes the realization of dancing to suddenly saying, hey, we have a new rhythm game. So you can see how the effort to try and make a player act decisively and on limited time horizons. This idea of borrowing from sort of Wolfenstein, giving yourself an overcharge in terms of health, but making that a temporary thing, that would theoretically, much the same way that I think that's intended to achieve in that game, sort of more risky behavior, because in the end you're not going to be getting the advantage of the overheal if you don't sort of put yourself out there. Of course, there's other risks too, right? Like maybe you have some armor and you don't want to see your armor reduced, so you still behave cautiously. Like personally, I haven't actually felt that being overhealed is that much of an incentive to change the way I play Wolfenstein, but whatever, like that's just me. Like I feel like it's still fair to say that that is probably one of the intended results that they have of that particular system. But yeah, so all that I'm trying to say here is that, you know, there is this idea of the max HP, that this is not necessarily the only way of handling it, right? That you can in fact imagine situations where you just simply increment self HP by some amount and don't worry about a max. But in this case here, it does want to check. So if you're already at your max value, you have self HP. Assuming that you are not at your max, you've taken some kind of damage, you have a new HP value, self HP plus amount. Now, if the new HP value is greater than your max, then it just sort of clamps it down to self max HP. I'm trying to remember. I remember in Godot there was some sort of clamp function or something like that. And this isn't like a bad implementation, but I know in some cases there are explicit sort of clamping functions or whatever they wind up getting called that help you out with this. And I'm sure there's sort of cleverer ways that you can do this. So like I guess it would be, you know, min new HP value and max HP or something like that. There's a few different ways that you could implement that. But this is fine. Like the intent here is quite clear, right? If you would overheal, we've decided in this game that the most that you can get is your max HP. It will tell you, so this is specifically telling you the new HP value minus the self HP. Presumably this is just to say, or probably to pass on to a message saying, you know, you healed 1 HP or you healed 10 HP. This is where you actually get the healing happening. And then to sort of tell you that it did its work, it returns the amount received. Assuming that it hasn't already done that, you know, if you're already at the top of your health. So under take damage, this is quite a bit simpler. In this case, decrement self HP by however much. And again, this could even one day be changed. So I know there's the current calculation now where your defense value is adjusting the amount. It's entirely possible that take damage will actually we'll wind up calling that later when the orcs and trolls start taking swings at us. But we don't need to think about this too much. This is fairly self-explanatory. I am going to have some tea though. Oops. Sorry, just 1 second here. I'm very lucky whenever I spill tea. It's always just in front or on the part of my keyboard that doesn't have any gaps. Okay, health will restore a certain amount of HP up to the maximum and return the amount that was healed. If the entity's health is at full, then just return 0. The function that handles this should display an error if a returned amount is 0, since the entity can't be healed. Oh, that's interesting. It should display an error if the returned amount is 0 since the entity can't be healed. Huh. Okay. One thing we're going to need is a way to not consume an item or take a turn if something goes wrong during the process. For our health potion, think about what should happen if the player declares that they want to use a health potion, but their health is already full. What should happen? We could just consume the potion anyway and have it go to waste, but if you've played a game that does that, you know how frustrating it can be, especially if the player clicked the health potion on accident. A better way would be to warn the user that they're trying to do something that makes no sense and save the player from wasting both their potion and their turn. I thought roguelikes were all about difficulty, though. But how can we achieve that? We'll discuss it a bit more later on, but the idea is that if we do something impossible, we should raise an exception. Which one? Well, we can define a custom exception, which can give us details on what happened. Create a new file called exceptions.py and put the following class into it. So this takes from exception. And that's it. When we write raise impossible an exception message in our program, the impossible exception will be raised with the given message. So what do we do with a raised exception? Well, we should catch it, but where? Let's modify the main.py file to catch the exceptions like this. So from copy, we will import traceback. Context present root console. I'm a little confused as to where that is, but well, it's not that big of a file, so and I can search if I have to. Here we go. Okay. So try, oh, and we're completely getting rid of the event handler. Well, we're probably actually just moving that into the try, so let's, you know what? And if something goes wrong. Now, I always heard that this is not a good idea. But I'm going to go with what the game is, or the tutorial's telling me here. I think it's because Control C is also handled as an exception. So if you just do this overall catch for exception, you can't actually Control C out of the program. I may be wrong on that, though. Again, that's just more sort of, you know, legends passed down from smarter people than me that have misunderstood. So traceback, print exception, print the error to standard error. Well, at least the line, it's changing all the lines. This is a generalized catch-all solution which will print all exceptions to the message log, not just instances of impossible. This can be helpful for debugging your game or getting error reports from users. However, this solution doesn't mesh with our current implementation of the event handler. Event handler currently loops through the events and converts them to get mouse information. We'll need to edit a few things in input handlers to get back on track. All right. So from actions, looks like we have too many, so we're going to put them line by line. So we've got action, bump action, escape action, Wait, okay, apparently not. Now under the class of event handler, we are... Oh, that's quite different. Okay. So now we do self handle, not events, handle action, self dispatch event. Why doesn't it like event? Event is not defined. Right, we need to change the signature. So event, and it's not context, it's event. So how much you want to bet I don't need to worry about that mouse over warning anymore. Okay, so handle action is a new one. Okay, so as it says here, handle actions returned from event methods returns true if te action will advance a turn. If action is none, false. Try to perform the action. Good God. All right. And if it doesn't work, this one seems to just be getting impossible. Self engine, message log, add message. Oh, that's actually a nice way of doing it. So yeah, I don't do that much with exceptions, but actually this makes nice sense, and it sort of is a nice visual way of sort of saying, hey, idiot, you did something wrong. Okay, false. Okay, yeah, and this is the part that keeps us from wasting our turn if we try to drink a bottle, a health potion on a full stomach. Okay. And after all of that, self engine handle enemy turns, self engine update FOV, turn true. I think there's also some, I think there's some sort of like finally or something like that you can do, but I think in this case that's not what we want to do, because if we did finally, I think it's regardless of what happens in terms of so I think the thing here is if we were to try finally, if I recall correctly, that would mean that regardless of whether or not there's an exception, we would handle the enemy turns. So what we want is try to perform the action. If there isn't a problem, then we move down to self-engine. This is funny, actually, because I've only ever seen sort of exceptions at the bottom, but this is making sense to me. So try to perform the action. If there isn't a problem, then the enemy turns will happen, and we update our field of view, and we return true. And if there is a problem, then we immediately get out of handle action, and it's as if the turn didn't happen. Okay, handle events is, well, that's gone. Game over event handler. So yeah, we completely get rid of these. No, we do still define key down. We just make it very small. So self event, tcod event, key down, none. So signature's changed. Is it yeah, signature also includes the return. This one. So basically, don't do anything unless somebody presses the escape key, in which case you raise a system exit. Which again makes me wonder, so for raising a system exit, that is an exception if I'm not mistaken. Yeah, common base class for all exceptions. So it would seem to me that if we played the game right now, I'm actually going to do this just to see if I understand this. So if I hit escape, okay, that worked. Now if I die, oh, doesn't take any of my inputs, so I don't have the option. Yeah, so I guess the thing that's weirding me out a little bit, so in addition to the fact that I can't move right now, what's weirding me out a little is that if system exit is an exception, and if in main we're always taking exceptions and printing them to the log, then presumably when we hit escape in the raise system exit, or no, even EV quit. Huh. So maybe I'm wrong about this idea of it capturing everything. Okay, well, that's not a major thing for me to worry too much about, but definitely the first thing that I would do in terms of talking about, like, so I sort of asserted that, right, previously, right, that I think if you do exception, then it just sort of absorbs everything, and that might be bad. Now, clearly we have an example where we've been able to successfully have a system exit, even though we're taking everything in. And so with that in mind, I want to sort of maybe check my assumption there in terms of saying, well, if I thought everything got absorbed by that, and if all of it's getting added to a log, why was it that I was still able to exit the game? So it would seem to me that that is an indicator that maybe that that idea that I communicated, either I misunderstood, something's changed, or that the behavior is a bit different. So, and again, certainly not the first time that I have misunderstood something and have said, that shouldn't work, and it winds up working in the tutorial. Okay, now that we've got our handlers updated, let's actually put the impossible exception to good use. We can start by editing actions.py to make use of it when the player tries to move to an invalid area. Presumably this would be trying to walk into a wall. And after color, so we're performing a melee action. So if not target, that would be interesting to see a case where that happens. Okay, if not self engine game map in bounds. Right, if I'm trying to get out of bounds. Oh, that's interesting. It says the way is blocked. It's not strictly true, but I guess we're implying a giant wall. I mean, this is a fantasy game. Shouldn't we write thy way is blocked? Thy way is blocked. Okay. If it's not walkable, we say the same thing. Finally, if there's a blocking entity at the location, possible of course, we shouldn't be trying to bump into the, or try to move into there. We should be attacking it. So it could be that this is just informing us that our attack didn't work as intended. Now, if you try moving into a wall, you'll get a message in the log and the player's turn won't be wasted. So what about when the enemies try doing something impossible? You might want to know when that happens for debugging purposes, but during a normal execution of our game, we can simply ignore it and have the enemy skip their turn. To do this, modify engine.py like this. Okay, so still adding exceptions. I wonder if there's an alphabetical reason for doing it this way. Handle enemy turns. So if entity AI, all right, so we're gonna wrap that in try, perform the action, didn't work. But we're only trying to catch an impossible pass. And I guess as far as debugging is concerned, it doesn't worry about that yet. This is great and all, but wasn't this chapter supposed to be about implementing items? And yes, that's true, and we're going to transition to that now, but it'll be helpful for us to have a way to stop the player from wasting a turn in just a moment. The way we'll implement our health potion, I'm really worried, by the way, that the way this is working, so we've made all these changes. Can I move? Yeah, I'm worried that I've actually done something wrong and I've stopped myself from being able to move. But we'll wait till the tutorial tells me to actually run things. The way that we'll implement our health potions will be similar to how we implemented enemies. We'll create a component that holds the functionality we want, and we will create a subclass of entity that holds the relevant component. From the consumable component, we can create subclasses that implement the specific functionality we want for each item. In this case, it'll be a health potion. But in the next chapter, we'll be implementing other types of consumables, so we'll want to stay flexible. Now, if you can excuse me for just a minute here, I probably shouldn't be drinking hot tea if I'm this warm. I'm just going to get the window. It's not quite as bad as it was earlier, but it's very humid still, so I'm not exactly the most comfortable broadcaster right now. That's fine. We'll get through this. In the components directory, create a file called consumable.py and fill it with the following contents. Okay, our friend annotations. Kind of nice. I mean, obviously this is just the way you write programs, but it is kind of nice in this tutorial. This is actually maybe what I'm trying to say here is one thing I kind of like about doing the tutorial and specifically trying to be a bit thoughtful in terms of what's happening and why, you get a little bit of a preview, almost sort of like a recipe in terms of how you're going to do this, right? So we've said that, okay, what are we trying to do here? Well, we have things in the game, right? So we call them entities, but there's, we gave the example in terms of Unity, right? How in Unity you can keep adding components to things. There are game objects, and game objects always have transforms. But other than that, it's sort of, this would represent everything from like mysterious sounds in the world to, cameras, players, anything you can really think of, and also things you can't think of. That's, of course, the power of programming and the power of using powerful tools that allow you to do things that other people haven't done yet. And again, this led me to sort of have a little bit of reflection in terms of saying, okay, so is this a very standard way of doing doing games is it very often that we have entities and we sort of attach components to them. There's a book by, is it Jason Gregory? I could be wrong on it. Anyways, someone, I believe they are still at Naughty Dog, but it's entirely about game engine architecture, and they sort of, there's a whole section on it on how sort of like object-oriented programming is, the place to be in terms of game development. Just it's, makes things so much easier. It's just in terms of representing things. And obviously it's a very persuasive argument given the way that, this tutorial is structured and so on. But yeah, it's just one of these things, right, where it's always nice to sort of say, okay, so, why is this the case? And in this case here, seeing as we've already been able to implement Fighter, you can try to sort of see maybe before you read a full recipe, you have at the very beginning, here are the ingredients that you're going to use. And we can sort of say, okay, so, we've got the typing stuff, and it's like, well, we kind of already know, we know this is related more to how we're writing our program. This isn't so much in terms of how the program works. And then we've got, okay, so we've got actions, we've got base component, and we sort of said that what we're doing here is sort of a consumable version of Fighter, so that seems to make sense here. We want to bring in impossible because, of course, this is the whole reason we implemented this exception, and so on and so forth. So I don't know, it's just one of these things where you could, in theory, do, so I guess the thing that I sort of think of is that if I were to copy and paste this whole tutorial, and this would obviously be quite difficult when it comes to the changes, just because, there's if I just copied and pasted without thinking, then this is going to betray me. But, there's nothing really saying that I couldn't just copy and paste this and move on. But clearly, if I want to get the most out of it, it's nice to just sort of say when I'm doing these imports, oh, okay, I think I know how this thing is going to be used. So, color, well, this is probably going to be for the message log. And actions, okay, now this is a little bit more about how, how we're interacting with it, right? We've got base component. This is going to be, giving us a little bit of a blueprint in terms of how it gets attached to an entity. But the action is going to be where we're like, all right, yes, this is, you push a button and here is going to be what happens. So anyways, that's roughly how I sort of think about this stuff when I bring it in. It's a little hard to voice in the context of a video other than just, taking the time to say this sort of stuff. But I don't know, I do where I can, if nothing else, just as a reminder for myself, right? Take the time to think about what is being brought in rather than just sort of passively saying, it's like, I'm sure this will all make sense after the fact. So we're making consumable. Presumably this inherits from base component, and it does. Parent item. So we're following the parent convention that was introduced in the refactoring. So we're going to do get action self consumer actor. Okay, activate. Doing great on the spelling mistakes. Okay. So, worth mentioning, and I know the tutorial already said this here, but why specifically do we do this? Like, why are we doing this specific wording here, right? Try to return the action for this item, actions, item, action, activate, invoke this item's ability. Action is the context for this activation. Like, weren't we talking about potions? Well, again, as the tutorial said, we're not just focusing on potions. We're about to implement healing consumable, as you can see from the class below. But what we're doing right now is we're saying there is a whole set of things in this game that you're going to interact with. You're also presumably you're going to interact with, and they're going to be used up, hence the name consumable. And so we are creating this general case of consumables before we start thinking about things that heal you. So you can see here we don't have an init for consumable, but we do have it for a healing consumable, and healing consumables are defined basically by the integer value that they'll heal you by, or that they'll do something by. I mean, presumably, if you really wanted to confuse people, you could make a poison healing consumable and give it a negative number, but I think you'd probably just want to create something called poison so that when people look inside the code, they'll know exactly that it's... Okay, that's actually pretty cool. This is presumably the code completion tools working the way that they're supposed to. So activate self, action, actions, item action to none. So we're not going to do that. We already defined heal, so we're good there. So make sure we actually healed. Okay, so you consume the self-parent name, Red Bull, and recover amount recovered. This is conditional on it being greater than 0. And HP and color health recovered just helps distinguish what happened in the message log. Else, raise impossible. No exclamation mark on this one, though. Heatle. Okay. The consumable class knows its parent and defines two methods, getAction and activate. GetAction gets item action, which we haven't defined just yet. We will soon. Subclasses can override this to provide more information to item action if needed, such as the position of a potential target. This will be useful when we have range targeting, so this would already set us up for tossing bombs, let's say. Activate is just an abstract method. It's up to the subclasses to define their own implementation. The subclasses should call this method when they are trying to actually cause the effect they've defined for themselves. Healing for healing potions, damage for lightning scrolls, etc. Healing consumable is initialized with an amount, which is how the user will be healed when using the item. The activate function calls fighter.heal and logs a message to the message log if the entity recovered health. If not, because the user had full health already, we return the impossible exception we defined earlier. This will give us a message in the log that the player's health is already full and it won't waste the health potion. So, what does the component get attached to? In order to create our health potions, we can create another subclass of entity, which will represent non-actor items. Open up entity.py and add the following class. Okay, so after base AI, from components, consumable, import consumable. So property is alive. right at the bottom there. So new class, item, entity, friend init. Again, quite cool that it does this. I'm just, yeah, this is not even close to what I wanted. Self star force keywords x integer 0, y integer 0, character currently a Now, one thing I'm a little curious about is that because we've used this default 255 all the time, I sort of wonder why this hasn't been defined in terms of color and just sort of said, you know, initial value or something like that. I'm not really going to question that, though, just because, you know, it's clear that this is intended to be replaced with something else. Names, dr. So I don't think it was wrong to populate the super init, but I'm not so sure I agreed with what it was putting in there. So in this case, I'll just do it manually. So we're talking about consumables here, so presumably you at most want to stumble over an object rather than have it fully block you. Okay, seems to me like we are ready to go. Item isn't too different from actor, except instead of implementing fighter and AI, it does consumable. When we create an item, we will assign the consumable, which will determine what actually happens when the item gets used. The next thing we need to implement that we used in the consumable class is the item action class. Open up actions.py and put in the following. So I already had that open. We are adding item now to the list. Getting a little cramped in here. All right. So again, we're defining item actions here. So between these two, we're defining, oh, no, that's not right. Class item action, which is subclass of action. Okay, I'm curious to see what happens when I do init. Nothing. Okay, cool. Okay, so taking the init from action, self item is the item. If there isn't a target, and the target is itself, okay. Next up, property. Would help if I had the colon. All right, let's try that again. Return the actor at this action's destination. What are you mad about? There we go. Return self engine game map. Get actor at location. Self target XY. And again, the little star here is just unpacking the X and Y coordinate out of the tuple. Okay, def perform. Is that right? Not even close. Okay. Consumable. Activate. Now, interestingly enough, there isn't an action, though. Oh, I love it when there's crying kids in the apartment building. I don't know if any of you can hear that, but I have to listen to this quite a bit at night. Okay, I'm a little shaky on what's going on here. But I'm going to kind of roll with it here just because there's already a couple of mysteries for me, such as, why can't I move? Like, shouldn't we have dealt with that at the time? So in this case here, I'm just going to sort of let the tutorial do its thing, and then I'll see if there are any remaining questions after all of this gets done. So item action takes several arguments, and it's a net function, entity, which is the entity using the item, which is the item itself, and target xy, which is the x and y coordinates of the target, quote unquote, of the item if there is one. We won't actually use this in this chapter, but it'll come in handy soon. Target actor gets the actor at the target location. This, by the way, is actually, I just want to comment, it is kind of interesting to see how this tutorial winds up working. Because it, like, I think it was I guess this would be 3 videos ago, but like there was definitely sort of a comment in terms of the tutorial saying that, yeah, I kind of want to do this a certain way, but I'm really busy right now, so this is how it's setting up. And you can actually sort of see some of that reflected in the way that this tutorial gets written. It may also be that the author's getting a little conscious about the length of some of these, because I think if we had done this earlier in the tutorial, probably target XY wouldn't actually be in here, and we'd be implementing it as we needed it. But I also don't necessarily think it's bad to sort of show, okay, we know kind of in the future we're going to want situations where we have items that target things other than we want to target things other than than ourselves. And so we're building in some functionality for that, even though we're not going to use it right now. I'm not quite sure which one is better. I do think I will note for myself that I am expressing confusion roughly around the time that the tutorial is starting to say, hey, trust me, this will become important a little bit later. And it's not so much that I think this is particularly confusing. In fact, I think I said what this would do prior to it being introduced in the tutorial. But what I do think is interesting is that I'm feeling quite a bit more uncertain about where I am in terms of the tutorial right now, which hasn't always been true in this tutorial. And while I think it's good to point out that this is also deeper in the tutorial, where we're sort of really getting into the meat of the game, I think little things like this might be reflections of the fact that some of the explanations might be getting a little bit rushed in here. So that might be why I'm feeling a little bit more lost. But we do, again, there's the 2 sets of solutions that I do. One is in the moment, if I think that there is some advantage to trying to unpack these things and maybe quizzing myself or trying, poking at the program a little bit and seeing if it works, I'm completely willing to do that. And sometimes just getting up, going away from the keys and maybe thinking about things for a little bit. Sometimes that's a good way to figure out how these changes work as well. So right now I'm just going to have faith in the tutorial, and then if there are any lingering questions at the end of the session, I can take some time and think about those. Okay, target actor gets the actor at the target location. Again, we won't actually use this chapter since health potions don't target anything. Perform activates the consumable with its activate method we defined earlier. To utilize our new item, let's add the health potion to entityfactories.py. Okay, so beneath components AI, components consumable from component. Good Lord. Healing. And we're bringing in both actors and items now. And at the bottom, presumably healing potion or health potion. It's an exciting health potion. Color should be blue, right? Okay, and I forgot the equals on color, so no function called color, but there is a parameter. We're defining a new entity type called health potion, no surprises here, and utilizing the item and healing consumable classes we just wrote. The health potion will recover 4 HP of the user's health. Feel free to adjust that value however you see fit. Now, of course, I wouldn't necessarily want to adjust this value until I see how often it's being added to the map, because there can be a couple of situations if you wind up with a couple of trolls in the map that you, I don't know if it would be impossible, but the likelihood of you being able to do enough in that map to survive is lower. And so what you might want to do is you might want to quantify the number of times that a troll situation like that is going to happen, and maybe distribute the health potions accordingly. And then, of course, what happens there is you are trying to it's not just that you're navigating the dungeon and trying to take out all of the monsters, but you're trying to navigate it in such a way that you have access to the resources that you need to survive the fights in the time that you need them, right? So the idea here would be is that I know there's a few trolls on this level and that I can't survive without a healing potion. So I need to find that healing potion in time to be able to take on the trolls. And I might be able to take on one at the start, but the risk that I run by taking on an early troll is that I may not find the healing potion. Of course, if I'm running around the dungeon too much, then I might sort of be swarmed by these enemies and I wind up in a situation where I'm not able to take advantage of my healing items. I don't know if that's a particularly sophisticated way about thinking of the design problem, but I've got a few levers to pull, more than I used to have, and it's one of these cases where I guess it's a little. I'm trying to remember. I think I was a friend from a game design program or something like that. They gave an example of one of their lessons was make a game where you can only press one button. And like to a certain extent, you think, that can't be a really fun game. And yet, if you play Roach Racer in Cyberpunk 2077, that feels almost like a student project, and it's actually quite engaging, right? Because you have that one button that you can press, but you can jump, you can double jump, you can glitch down to the bottom. You're trying to avoid enemies with different movement patterns. You're trying to get certain rewards. It's a nice little example in terms of something that I'm assuming is I'm sure that's something like the Hello World of game design examples, just based on the fact that they told me that, and then I see something like that later in a game by a developer in a completely not even a completely different country, a completely different continent. So yeah, all that I sort of want to say, right, is that where I can, the reason I'm not really trying to pad out the runtime on these things, but it's nice where I can when there's a new concept that's entered in. It's sort of like, okay, I've moved from that one button level or that one button game, and now I have a second button. And sure, I can say, okay, well, I have, two two actions that I can take. Well, no, there's actually a lot of different ways to there's a lot of different ways to sort of interact with the game. And obviously being able to push two buttons, you have the variety, we'll go back to Roach Racer, right? You have not just the jump, but the double jump and the glitch. Likewise, you have sort of a similar set of behaviors with that second lever that you can pull. And then finally, you can add the interactions. And then, of course, presumably those interactions can also occur at different phases, right? An interaction with the glitch might be different from the interaction with that initial jump. And so it's not just that you have two actions that you can perform now, but the combination of the two, depending, again, you probably wouldn't want to do the math. And there's like combinatorics where you can sort of say, it's like, okay, if I had 4 buttons, what can I do? You probably don't want to do that because there are just certain combinations that either don't make sense or they are physically hard to do. And so, you don't want to completely just math it out. But it is also sometimes nice to just, again, when you have something like a health potion introduced, it's like, why do I need the health potion? I need the health potion because right now, if there's a certain number of trolls that enter into the map, it's impossible for the player to win. There's just simply not enough hits that they can perform to be able to take out trolls. So it's like, okay, so knowing that, how many health potions should I put on the map? If I put too many, the level's trivial. If I put too few, it's likely that it's, there's no way that I can access them in time for me to use them. Is that the only option? What about armor? Can I get armor that maybe breaks after a certain number of uses? That's equivalent to a potion, but it doesn't involve the player hitting certain buttons and sort of building up this infrastructure. It's like, okay, well, you could do that, but that also means that the orcs can't do any damage. And it's like, well, that would actually be kind of interesting, wouldn't it? Because what you then need to do is you need to make sure that you use your armor at an appropriate time to fight the trolls. And if you waste a lot of time on the orcs, all that they're going to do is ding up your armor at the time when you need it the most to be able to take on that troll. And again, I don't want to try and imply that these are like groundbreaking or really good game design decisions. They're, I think probably the safest rule for myself is to say, the first time I think about anything, it's probably very stereotypical or very boring. But if I can, it's sort of nice to try and have some purpose behind some of the things that I'm thinking about or doing, just so that I can get a better understanding about why certain things are going in. Because there will be a point where there's lots of different items inside of it, and I don't have the option to think in such a clear way about what these different items do, right? It's not like I want to sit down and sort of meditate on the nature of, an attack +1 potion every single time it gets added. But taking the time to sort of say, okay, when we've added a new thing in here, why, what purpose does it serve? Is there a problem that's being addressed by it? Or is it perhaps creating new problems? And then from there, sort of thinking it through. So anyways, we're keeping it at 4. Sorry for the rant, but this is how I try and sort of take ownership of the knowledge as opposed to just type away things somebody else has already written. All right, now we're ready to put some health potions in the dungeon. As you may have already guessed, we will need to adjust the generate dungeon and place entities function in procgen.py to actually put in the potions. Edit procgen.py like this. So off the top of my head, I don't know if it would do it in here, but given the fact that the trolls are the real killer in this game, I would actually probably make the number of health potions proportional to the number of trolls that get generated. That's probably more complicated than what they want to do at the start, though. So, and again, as you can sort of see, right, I've got a very troll-centric kind of way of thinking about this game. maybe that's not the most effective way of thinking about it. Maybe that's undervaluing the orcs and the roles that they have inside of the game. So, but on the other hand, I don't think that's completely unfair for somebody whose experience has been to play games to think about the. I don't think this is the right one. No, hang on. They did say open procgen. As a player of games, I'm not entirely sure this is an unnatural way to think about it, right? Because what is the thing that just about every video game player knows, right? You play games so that you go up against the boss, and when you take out the boss, it's a big satisfying feeling at the end. So, whether you're giving Bowser a lava bath or, you're taking some preposterously large, FromSoft enemy and bringing it to its knees, like everybody understands, taking down the boss is the feeling of satisfaction. And there's 2 enemies in this game and the orcs aren't the boss. So that's probably going to be why I have a very troll-centric view of the game. Okay, so place entities, we are changing room. So we've got rectangular room, dungeon, maximum monsters, maximum items. Okay, and then we're adding number of items. After factories troll. So same logic from the placement of the monsters. We're just trying to avoid certain parts of the room. Not any entity x equals x. Now this is actually kind of interesting. So in this case, they're specifically saying avoid entities. I'm not entirely sure that that's necessary here. Right, because if you think of it, for entity in dungeon entities, okay, so like there's a couple things that I'm thinking about here. So we're saying that if there is an entity already on the map, don't put a potion there. And I believe in this case, actually, that just denies you the number of, yeah. So for instance, if we did number of items and we wound up with 1, and we're unlucky enough that there is a troll sitting where we wanted our potion, well, too bad. And it is maybe worth mentioning, right, that we're placing all of the items after all of the monsters have been placed. So in fact, the thing that is most likely, if you think in terms of likelihood, right, orcs are the most likely to be placed, then trolls, and then items, because the dungeon will already be populated. So the orcs and the trolls are simple to see because of the random generation, but because of the order in which all of these things are called, when we are iterating over the number of items, because there are already entities on the map, there's the danger that we spawn a potion where there is an enemy, which means that there's the potential that we have, I mean, as a theoretical possibility, it could be that we generate the largest number of items possible and absolutely no potions wind up on the map. And in fact, that becomes the perverse part of this is that it actually becomes more likely the more monsters there are on the map. Now, do I think that's very likely? No. I mean, there's a lot of different squares in a given level, so that would be a fairly incredible set of events. But mathematically, there's nothing saying that that would happen. Of course, if you I imagine that if you change this program a little bit, you could just get it to iterate over a whole bunch of different games and then have it sort of print out some summary statistics of the maps that you did. So you could sort of say, let's pretend that we put this on Steam, it became a hit. How many of these unfortunate players wound up with effectively impossible levels? And how many of those levels were specifically because of the placement of some unlucky enemies? Or I guess the enemies were lucky, the unfortunate placement for some health items. Again, this is purely for fun, but I don't know, I feel slightly inclined towards changing the health to the number of trolls on the floor. I suppose you'd maybe want to change that as the game starts adding new levels. You'd probably want to think a little bit more about how you're doling out the healing over time. But yeah, I don't know. It's fun to think about the implications of some of these. Okay, on to generate dungeon. So we need to add the max items. And then I think we just do max items here. We're doing essentially the same thing we did to create our enemies, giving a maximum possible number for the number of items in each room, selecting a random number between that and 0, and spawning the items in a random spot in the room, assuming nothing else already exists there. And again, actually, sorry, I wanted to be a little more clear. I'm going to blame the temperature. I was less clear than I wanted to be on this. So there are two things that I would probably change in this sort of prior to playing it. I like the idea of potions relative to the number of trolls, because those seem to be the thing that require you to get health. And I'm not so sure I like this idea of potions spawning, not always spawning off of enemies, because it sort of seems to me that one of the most recognizable game experiences is you have something that you want, right? It's the princess, it's the weapon upgrade, it's the key to a room that you want. Like, there's any number of different things. And you go get it, and all of a sudden there is a tough enemy in the way, right? It is the reason why you go after that enemy, as opposed to just running off, or I don't know, playing solitaire or something like that. And, I don't want to come down too hard on the tutorial on this, because the fact of the matter is we are never going to have that experience in this game. As soon as an enemy sees us, they're going to move off of that item and come after us. But, it does kind of deny that experience. I mean, I think even the enemy moving towards us, the most likely scenarios are one where, again, I'm specifically thinking of the troll here. It's like, oh, I really need that health. Oh no, he's moving towards me. He's closing the gap. And then you sort of have that moment. Is there a way for me to move around the troll to get it? Or maybe you're really close to losing all of your health. It's like, is it possible for me to take a couple of bits of damage while I try to run around the troll, knowing that I'm going to be able to get the healing? Now, the fact that it gives you 4 is probably the answer to that is no. It will never be worth it to try and run around the troll. But to make you think about that I think is kind of fun. So those are a couple of gripes that I have with the simple implementation, but I'm not going to be too cranky about it. Now, this is interesting. So the tutorial here seems to indicate that I should be able to move my character, and I have a feeling I'm not going to be able to. But let's not speculate. Let's actually load it up. All right. Debugging time. Actions.py line 6. Oh, do you not open? Here. From engine import engine. I think this is a... I think this needs to go... Oh, yeah. No, of course. I have a feeling we probably can't bring an entity either. I'm sorry to go all the way to the top here, but I have a feeling that I missed a few things. All right, so let's do... Okay, I tried. Okay, nothing in game map. This is base component, fighter, main, input handlers. Interesting. So I think this is still going to complain. Cannot import actor from partially initialized module entity, most likely due to a circular import. Entity.py. I'm wondering how some of these crept in here because I don't feel like I changed them. But like nobody else would, right? So I'm kind of curious where these came in. All right. The super argument needs a... I don't think the problem's with this one. So we've got item, character, color, name, health potion, consumable 4. Descriptor of init needs an argument. Am I completely losing my mind here? Okay, let's just make sure that I'm not completely, so I've got consumable, import healing consumable, actor and item. Okay, those are fine. Entity, we have actions. Okay, item, entity, def init, self, star, 0, 0, car, tuple, unnamed consumable. That's it. It's completely maddening too. Okay. Generate dungeon needs max items per room. I feel like I skipped over a whole section. Yeah, I almost certainly did. Okay. Lastly, to make our health potions appear, we need to update our... Yeah, I don't know what was going on here. So giving a maximum possible number of items for each room, selecting random number between that and 0, spawning the items in a random spot in the room, assuming nothing exists there. Lastly, to make our health potions appear, we need to update our call in main.py to generate dungeons since we've added max items per room. Open up main.py. We've got max monsters per room, max items per room 2. Do the usual thing. Game map after monsters, we do max items per room, comma. Okay, well, we could open it. And our movement still doesn't work. I'm just going to try all the keys. But escape does. So, I was right to be worried about the movement. Clearly something went wrong here. But that's the fun of doing this work. Okay, so we've got action, bump action, escape action, wait action, which haven't... So I note that bump action and wait action are not called. So under event handler, we have an init, we have handle events, which is self action, self dispatch event. We have handle action, handles actions returned from event methods, returns true if the action will advance a turn. If there's no action, then it's false. Otherwise, we try to perform the action. If it is impossible, then we add the message to the log and we return false. So how much you want to bet this is just a question of tabbing this back to not according to this. Nope, these should be on their own line here. Okay. So handle events honestly isn't all that different. I've completely removed main game event handler. This feels wrong. So if the main game event handler Well, okay, so I sort of understand. So what we've done here is we had a main game event handler, which said that, okay, context, convert event, so on and so forth. And what we've done here is we've taken this part, and that seems to have largely been elevated up here. Now, again, there's a couple of maybe distinctions that I would draw. So well, no, not even really, because it's action perform. Okay, so let's just say that's, that's all well and good. We've moved this up to the superclass. So is the problem in action? Okay, so we have a movement action. We try to perform it. We've got our destinations here. If you are not self-engine game map inbounds, destination X, destination Y, we raise the exception that the way is blocked. I guess I should put the okay, so we're performing self. We've got destination X and Y. We're saying if it's not in bounds, if it's not walkable, if it's blocked by an entity at destination X, destination Y, we say that it's impossible. If none of those are true, then we perform the move action on self. That shouldn't stop us from moving. So I'm going to guess it never gets here, but I want to see specifically what happens. Yeah, so it never gets to the move action. So I feel like there should be this point here where it checks the move keys. This is the thing that's weirding me out a little bit. I don't see a situation in which we say, like, there's the history viewer here, but I don't see the point where we actually check the we check the like key. Okay, so we've got the main game handler, EV key down. If it's tcon event escape, we raise the system exit. But that's not enough. We want to also see if it's within the movement. So this is the game over. Oh, hang on. Okay. This is on me. I took def key down. Ah! All right, so I think I can just undo. Yeah, let's just go all the way back to changing the imports. We'll do this all over again. I'm sorry, again. It does feel a little... I can actually probably take it from here, but I just think it's better. I think it's better to take it from the imports. So the one thing that feels a little bit bad about this is that I did feel uncertain at certain points of the tutorial here. And clearly some of what I was feeling was related to an error that I introduced. But I also think that there's still some confusion that kind of comes from the way some of the things are defined. Oh, wow, it started raining. Sorry, I'm easily distracted. Also, my windows are not the cleanest, so I probably should have noticed that a little earlier. But yeah, So yeah, there was that uncertainty that I felt, and obviously one of the things I felt uncertain about was something that I introduced, but there's another set of things that are not related to this uncertainty that I felt regarding the inputs that still isn't quite resolved. So I think probably the answer for this, especially because it's getting on a bit, I will fix this all up. I'll make sure that the game runs and that we don't have any errors or anything like that. And what I might do between the two videos is I might take some time for myself to really like sit down and make sure that, okay, so where I was feeling a little uncertain in terms of how the items were set down and things like that, do I feel reasonably sure that I understand how these are working now? But I'm not entirely sure that's an investigation I need to do on the video right now. And again, maybe this will all just come into place as soon as I see the game in action. So we're bringing in exceptions. We have already gotten rid of action, bump action, escape action, etc. I already feel a little weird here about these move keys because this isn't part of this file right now, but it's not like I moved them. Let's do our best. So we're just going to we'll move beyond these. We'll say, okay, we've got event handler. So we are going to change handle events. So it is an event now, and it's tcod event. Okay, so now we will add handle action. Okay, so we need the accept. Okay. So handle events has been handled up here. We've added handle action, which doesn't require anything else. So now we move down to main game event handler. So we have handle events. We want to get rid of for event and tcod event wait. Don't convert. Don't self-dispatch. Don't if action is none. Don't action perform. Don't self-engine. Don't self-FOV. But we do still want to keep key down. And that was the shooting offense right here, the fact that I got rid of this. All right, so for handle events and EV key down, okay, so we'll just get rid of handle events again. I think that's all handled upstairs now. And then this just gets simplified. So it's still event key down, still returns none. We retain event sim. Should probably make well, I don't know. The cursor Y keys do sort of make sense to sort of keep here. I do feel, though, that the constants are just sort of lying around now. I don't know, something for me to think about later. Okay, so that should address the insanity that I put into this game. So, cool. We'll dispatch these two. Remains of an orc. Remains of an orc. So let's see what happens when we bump into something. The way is blocked, 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 blocked. Blocked, blocked, blocked. Blocked. Wait. Okay, all of these are working. I want to see the potions. Wow. Works perfectly. Now, I guess we don't really have any interactions, right? So I've got a health potion, but I don't have any way of picking it up. Oh no! What do I do? All right, so I'm gonna just take, oh, wow, this place is full of them. I'm gonna kill the player off just so I can see if the escape works. I guess for completeness, I should do one where the player dies and then escapes, but also one in the main game. So I can't move. Can't escape. That works. No complaints. Okay, cool. No warnings, no madness. We have crash landed the disaster. That was my adjustments. These potions don't do our rogue any good right now because we can't pick them up. We need to add the items to an inventory before we can start chugging them. To implement the inventory, we can create a new component called inventory. Create a file in the components directory called inventory.py and add this class. All right, our friend future import annotations from typing, import list type checking from component. Oop, nope. Let's import wrong one. Base component, import base component. Looks like there's a problem. Nope, just was impatient. If we're type checking, then see about the entities. Entity, import, actor, item. Okay, inventory, base component, parent, actor. We initialize. Not even close. I'm assuming it says something like at the player's feet. Let's just see. Okay. I guess technically the player doesn't have feet. Of course, we've already put the place. I think the place was originally designed to move between levels, but this is obviously helpful in terms of dropping items. I suppose one thing that's an interesting implication out of this is that there will eventually be seems like there will eventually be a limit to the inventory. And so you'll have to sort of make some hard choices in terms of what you want to keep, which I think would be kind of neat. The inventory class belongs to an actor, and it's initialized with a capacity, which is the maximum number of items that can be held, and the items list, which will actually hold the items. The drop method, as the name implies, will be called when the player decides to drop something out of the inventory back onto the ground. Let's add this new component to our actor class. Open up entity.py and modify actor like this. I've added the inventory. Where's my actor? And okay, now each actor will have their own inventory. Our tutorial won't implement monster inventories. They won't pick up, hold, or use items, but hopefully the setup gives you a good starting place to implement it yourself if you so choose. We'll need to update entityfactories.py to take this new component into account. I was going to say, why didn't we do this in type checking, but we didn't. We're not checking types, so and that makes sense because it's a factory rather than defining things. Okay, so actor fighter inventory equals inventory. You can have a whole alphabet in there. It's funny. I was thinking, small inventory, so you have to make some hard decisions in terms of what you hang on to, and it's like have 26 items. I'm like, okay, I'm never going to have that many. Especially given I think maximum potions was like 2. We're setting the player's inventory to 26 because when we implement the menu system, each letter in the English alphabet will correspond to 1 item slot. Okay, so that wasn't coincidental. You can expand the inventory if you want, though you'll need to come up with an alternate menu system to accommodate having more choices. In order to actually pick up an item from the floor, we will require the rogue to move onto the same tile and press a key. First, we'll want an easy way to grab all of the items that currently exist in the map. Open up gamemap.py and add the following. Adding an item after actor. After actors, we are adding another property. Okay, def items self returns an iterator of items. Yield from entity, whoops, for entity and self entities, if isn't. Cool, that wasn't so painful. We can use this new property in an action to find the items on the same tile as the player. Let's define a pickup action, which will handle picking up the item and adding it to the inventory. Open up actions.py and define pickup action like this. I think we're just adding this at the bottom. Excuse me. Just feels wrong not to have a space between them. So this is just like any of the other actions, right? We have our initialization, we have our perform, and in this case, what we're going to do is we're going to interact with the inventory, which was previously something we didn't have to worry about, and presumably the next step will be to go into our key maps and define a pickup button. Okay, so we return none, actor location x entity x y, same deal, inventory self entity inventory for item in self engine map items. If the X and Y location is the same as the item location, inventory, right, we need to check capacity. Okay, so we've picked up the item now. Move it into our backpack. And this is actually one that I wouldn't have thought to include, so it's good that they did, but raise exceptions, impossible. So after all of this, right, so you have performed the pickup action, it's got your X and Y location, it's got your inventory. You say, all right, all of the items in the map, do any of them match the X and Y coordinates? So it's like, right, we found something at the coordinate we're at, what do? We check to see if the inventory is full. If we have more than 20, or sorry, if we have 26 or more items, then we say, you know, you should probably drink one of these things before you add it to your backpack. Assuming that that hasn't happened, we remove the item from the app or the map. We put it in our inventory. We also say, hey, you belong to me now. And we display a message saying that we picked up the item after all of that's done. And if we are still in this function, right, what this is implying is that we've gone through the entire, all of the items inside of the game. None of them were at the location that we were at. We raise an exception saying that there's nothing here to pick up. And that is one I wouldn't necessarily have thought of and would have effectively counted as a wait. But given that we've already established the convention inside of this game that you cannot waste your turn, that would have been bad. That would have been something that would cause the enemies to attack. And, you know, I don't know. I'd put it to you this way. I don't necessarily think it's wrong. Like, if you want to have there be some consequences for like fat fingering a pickup button or something like that, you know, that's a choice, right? The one that would be harder for me is not keeping consistent with that choice, right? If either you want to always have that result or you say, okay, you know what, let's give them a break. So let's move on. The action that gets the entity's location and tries to, the action gets the entity's location and tries to find an item that exists in the same location, iterating through self-engine game map items, which we just defined. If an item is found, we try to add it to the inventory, checking the capacity first and returning impossible if it is full. When adding an item to the inventory, we remove it from the game map and store it in the inventory and print out a message. Then we then return, since only one item can be picked up per turn. It'll be possible later for multiple items to be on the same spot. If no item is found in the location, we just return impossible, informing the player that there is nothing there. Let's add our new action to the event handler. Open up inputhandlers.py and edit the key checking section of main game event handler to add the key for picking up items. I know this one well. Okay, so after escape action, we add pickup. I will also add the comma at the end of wait action, even though it feels a little weird to do. And then, where were we? So after V, oh dear. Okay, that wasn't too painful. Simple enough. If the player presses the G key, G for get, we call the pickup action, run the project now, and pick up those potions. Uh-oh. Item is not defined. I think there's got to be a colon here. Let's just double check that though. I also kind of have to go to the bathroom, but I know we're close to the end and it would be better if I can just do this in one go. Self items list. Yeah, so just a misplaced colon. Okay, no warnings yet. Picked up the health potion. I don't have any way of using it, and I'm fighting 2 trolls, but charge of the light brigade time. Into the valley of death goes my rogue. Holy hell, how many trolls are there in this thing? If only I could use these potions. That's actually a really neat little, so that as far as the pathing went, we got to see a neat little, there's a lot of potions in here. I thought there was, oh right, 2 per room. Uh-oh. We're dead. Okay, now that the player can pick up the items, we'll need to create our inventory menu where the player can see what items are in the inventory and select which ones to use. This will require a few steps. First, we need a way to get input from the user. When the user opens the inventory menu, we need to get the input from the user, and if it was valid, we need to return to the main game's event handler so the enemies can take their turns. To start, let's create a new event handler, which will return to the main game event handler when it handles an action successfully. Open the input handlers.py and add the following class. So after event handler, we add class ask user event handler. Okay, let's take a minute to think before I go any further. So handle in action, if super handle action, action. Okay, so there is basically if we get something other than like a none or a false or something like that, then the event handler, main game event handler, self engine, return true, return. Yes, no. Okay, right. As the description says, return to the main event handler when a valid action was performed. Had a moment of doubt there, but that's clear. That shouldn't have required that much thought. So def ev key down, self event, tcod event key down. Nope. Right, so not every key produces an action, so it's optional. By default, any key exits this input handler. If event sim in ignore modifier keys. I never remember these. Event key sim. I am a complete disaster as far as typing goes. Okay, so we don't do anything on a key down. Oops. No, stop. I'll confess the return self on exit is a little unusual for me. I am going to rely on the tutorial to explain that to me. V mouse. Okay, mouse button down. Okay, not bad. Just doesn't seem to have learned about optional yet. Oh, sorry. Right. We're talking about a bunch of default behaviors here. So in this case, yeah, this is why this is all exit stuff. So presumably the implementations that we'll do next will actually define things like drinking potions. So there's a side of me that kind of wonders why we're doing this, but that would be about par for the course for most object-oriented things, which is like I only sort of realize after the fact the bigger picture and how this enables a lot of other activity. Generally, if I'm in a situation where I wind up making decisions like this, or if I had like a class or something along those lines, it's because the program's already become so unwieldy and I say, okay, probably I should actually use some of these really helpful tools that are already in the tools that I'm using. And then, I just have this whole miserable experience. I write it once and then I write it again more like this. Now, again, I don't use classes a whole lot. I'm very often not doing big, complicated programs like this. So I think some of my confusion at these points is just, it's not a first response that I sort of have. This is something that I usually have to get into trouble before I start doing. I'm just going to take some tea because it's been 2.5 hours. Okay. I also see that there is a problem, but we'll handle that later. What's the point of this class? By itself, nothing really. The reason I was confused. But we can create subclasses of it that actually do something useful, which is what we'll do now. Let's keep editing input handlers and add this class. This handler lets the user select an item. Happens then depends on the subclass. Title. Missing title. A lot of typing. Render an inventory menu which displays the items in the inventory and the letter to select them. Definitely not doing 79 character lines. We'll move to a different position based on where the player is located. So the player can always see where they are. Super on render console number of inventory length self engine player inventory items height equals number of items plus 2 height less than or equal to 3, height is 3. So if we have a small inventory, we still have a minimum size for the screen. If self engine player x less than 30, x equals 40, else x equals 0, y equals 0, width equals length, self title plus 4. Console draw frame YY width height title self title clear true foreground is 25 5 to 5. I'm assuming here that there's some subclass which actually defines things like titles and such. Background 0 0 0. All right. If we have an inventory for I item in enumerate. So if it's not clear what enumerate is, basically it creates, it doesn't just return the iterator that you have, but it gives numbers. So in this case here, I believe it's actually starting from 0 to 1, but there's a little cleverness that it does here to turn those numbers into letters. So self engine player inventory items key equals char ord a plus I. So the idea here is if we're enumerating through a list, and we can have up to 26 items, first item in that list will be 0. So we get the number, the character key is ord A character plus 0. The next one is A turned into a number plus 1. So it's all in relation to A. And basically, if A, B, C, if it follows A, B, C, D, if the numbers keep going up for that, which they do, then all of your item keys are sort of mapped doing that enumerate. So you could conceivably do this in some sort of weird like comprehension or like iterator or something like that, but the first thing that I have learned, and I think probably the most useful thing to remember, is that nobody gives you points for being clever in that, and they usually hate you for making it more complicated than it needs to be. So console, because the point of this is to print out in the console what you can do, like what button do I press to get my my item, and that's very clear from this code here. Well, maybe the ord stuff is a little clever, but this is perfectly clear in terms of what it's doing. Okay, that doesn't work because we need key. This will be interesting, right, to see if the interaction, so right now we've got tcod event key A. It'll be interesting to see if key minus event key sim A will actually produce the same result. Okay, if it's between 0 index 26, try selected item, player, inventory, items, index, that's index error. Right, so we tried to push a button for something that, you know, we did Z when we had 2 items in our inventory. Says you can't do that. So this is a nice little way of avoiding us to like have to write every A through whatever. Again, I'm hoping that key sim's behavior is the same as whatever event key A was supposed to be, but I'm assuming it is based on the way it kind of told me to shift over. Okay, finally we implement on item selected, def on item selected, self item, item, return an optional action. Oh, we don't implement it now. We're done. Inventory event handler subclasses ask user event handler and renders the items within the player's inventory. Depending on where the player is standing, the menu will render off to the side, so the menu won't cover the player. If there's nothing in the inventory, it just prints empty. Notice that it doesn't give itself a title, as that will be defined in a different subclass. More on that in a bit. The EV keydown function takes the user's inputs from letters A through Z and associates that with an index in the inventory. If the player pressed B, for example, the second item in the inventory will be selected and returned. If the player presses a key like C, item 3, but only has one item, then the message invalid entry will display. If any other key is pressed, the menu will close. This class still does not... right, so if I pushed like a 2 or something like that, okay. This class still does not actually do anything for us right now, but I promise we're close. Before we implement the menus to use and drop items, we'll need to define the action that drops items. Add the following class to actions.py. Okay, so after escape action, class drop item action. Simple. Drop item will be used to drop something from the inventory. It just calls the drop method of the inventory component. Now let's put this new action into, well, action. Open up input headers, handlers.py once again, and let's add the handlers that will handle both selecting an item and dropping one. Okay. So apparently we're just straight up importing. So I'll be honest here. I'm not going to remove this, but I am a little confused now as to why we are importing actions and then specifically importing action, bump action, escape action, pickup action. Presumably you do one or the other. But the thing is, I would have to then take action and do actions.action, and I don't want to do that right now. I'll just follow. I'll follow blindly. Again, charge of the Light Brigade. Okay, after inventory event handler, we go down to class inventory activate handler. Inventory event handler. Handle using an inventory item. Title, select an item to use. Def on item selected. Close. Okay, and then we make class inventory drop handler, inventory event handler, dropping an inventory item. I'm assuming it's auto-populating the actions.item for the same reason I said, wouldn't you just get rid of the individual imports? Could be wrong. What on earth am I thinking? Let's try that again. Okay. At long last, we've got the inventory activate handler and inventory drop handler, which will handle using and dropping items respectively. They both inherit from inventory event handler, allowing the player to select an item in both menus using what we wrote in that class, selecting an item with a letter, but both handlers display a different title and call different actions depending on the selection. All that's left now is to utilize these event handlers based on the key that we press. Let's set the game up to open the inventory menu when pressing I, and the drop menu whenever pressing D. Open input handlers.py, and add the following lines to main game event handler. It's here somewhere. There we go. Okay. Nope. All right. Now when you run the project, you can at long last use and drop health potions. Let's see whether or not this actually runs first. Actually, hang on. Before I do that, it looks like there is a warning or an error here. Oh, yep. Okay, that solves the problems. So yeah, let's see if this thing runs before I... My God. All right. So G to pick it up. Whack, whack. Sorry, I've been having too much fun. Okay, so what I'm going to try and do now, so it was I to check the inventory. Aha. Inventory activate handler object has no attribute title. Did you mean capital title? I did mean capital title. Okay, so before I do anything, what I'd actually like to do now is try, so if I hit G, so notice that the orc didn't move. If I try I, it's empty. If I try D, yeah, can't select an item to drop. Let's just hit A, invalid entry. So got it. Whack the orc a bit. Again, make sure that in terms of blocks we're fine. So now I could do I. We're not going to use the health potion yet, so I'll hit 3 to get out. D. All right. Inventory object has no place. Self place. That doesn't seem right. Thought we'd... Okay, yeah, we define that much higher up. Inventory drop, self items remove, self place, no? Self parent X, self parent Y, self game map. Okay. Okay, so I'm wondering here, so it says that inventory has no attribute place, but it shouldn't be an inventory that has it. It should be, oh, item.play. That's the silly. Okay, as always, G, nothing to do, I, D, okay. I, D, drop it, get it. Just gonna get all the potions if I can. I want to try and make a somewhat full inventory. I don't think I'll get to... Ooh, okay, so inventory A. Interesting. Just keep chugging them. That was obviously not a good way to fight the troll and the orc, but... Oops. So on the note of unintended actions, the fact that the G is next to the H, so the Vim or VI cursors, this is one of these cases where I sort of agree with the idea that you don't want to punish people for unintended actions. But the funny thing is, because of the hope, and like I totally get why you want to do the VI or V or however you pronounce it. Totally get why you want to do those key bindings, because they're part of the history, right? I believe Rogue originally used those use that convention, but it does have the consequence where if you push the wrong button, you move instead of heal, and you can easily see some situations in which that would anger someone. So now we're going to really put this thing through the paces. We're going to just pile on a bunch of health potions. Yeah, it's struggling with that. Okay, but we seem to have put this through the paces. All of the actions work, and more importantly, we were able to survive a dungeon that we otherwise wouldn't have been able to. So yay us. Fun. I think we need to scroll down. I am sorry, this is 3 hours. There's a major bug with our implementation, though. Oh, and I didn't notice it. Used items won't disappear after using. Okay, actually, that's fair. I didn't really appreciate that the inventory wasn't getting smaller, but I wasn't really paying attention to them, so my bad. This means the player could keep consuming the same health potion over and over. Let's fix that by opening up consumable.py and add the following. Import components.inventory, and inside consumable, after activate, we define consume, self none, move the consumed item from its containing inventory, entity self parent, inventory entity parent is instance inventory components inventory. Oops. Inventory items, remove entity. Okay, then healing consumable, right, self-consume, and that should cover it. This is one of the things that really makes me appreciate the approach here. So again, like I've commented quite a bit on how this is different from what I am accustomed to, but the fact that when we say, hey, we're not actually getting rid of potions when we consume them, let's deal with that. The fact that it's usually just 1 or 2 lines does sort of sell me on why this is a good way of doing it. Again, unfamiliar doesn't mean bad. Unfamiliar just means sometimes it takes me a little bit to get on board with what's happening. Consume removes the item from the inventory container it occupies. Since it no longer belongs to the inventory or the map, it disappears from the game. We use the consume method when the health potion is successfully used, and we don't if it's not. With that, the health potions will disappear after use. There's 2 last bits of housekeeping we need to do before moving on to the next part. The parent class attribute in the entity class has a bit of a problem. It's designated as a game map type right now, but when an item moves from the map to the inventory, that isn't really true anymore. Let's fix that now. So this is, wait a minute, entity. So from typing, import optional tuple type var, type checking, and union. Right, so it's saying this can be one or the other, I think. Yes. All right, lastly, we can actually remove escape action as it is just handled by the event handlers. Open actions.py and remove escape action. This is always kind of a funny thing where once you hit a certain level with a program, you're actually really, really happy to delete parts. Because of course it just means that, when you add more features, but you can do it in fewer lines of code, that just makes it easier to maintain. But it is such a surreal experience to say, oh yes, all that hard work. I'm so happy to get rid of that. Then remove escape action from input handlers.py. And raise system exit. This was another long chapter, but an important step towards a functioning game. Next chapter, we will add a few more item types to use. So before we commit all of this stuff, let's just make sure the game works. We don't have any problems. Okay. I don't quite have... Okay, so now's a good time for me to use the health. Okay, we're empty on the inventory. Could really use some health now. There we go. Leroy. There's really no reason for me not to be drinking these potions now, but we like to live dangerously. It's funny, I naturally say A, B, but the inventory actually shifts each time you consume an item. I'm not entirely sure I would want to change that, but... Cool. That is the level. So it looks like everything's working the way it was. I'm going to take... It's a 3-hour episode, so I do apologize for that. I will commit... Actually, there's one other thing I want to do. So see the code so far in its entirety. The only thing I would like to take a look at is under input handlers, we have... it looks like the code actually gave us something different in terms of move keys. So I'd kind of like to see what's going on there. So after type checking, nope, they also have move keys. Wait keys. Oh, no, this is interesting. I don't seem to recall being told to add confirm keys. Nope. Okay, well, that's not it's nothing to get that's nothing to get bent out of shape on, but I will think about that when I go into the next ones. I'm also trying to remember, I think there was something about the inventory where I thought there was supposed to be another can't be the selves that I was getting confused by, was it? I don't know. I'll go over this and see if I can remember that one thing that caused me a bit of confusion, but we're obviously at a point here where we can commit. So we'll add all of these. Part 8, commit. We won't sync because I'm sure before the end of the night, it's getting a little late. Before the end of the night, I'll probably get part 9 in. But again, it was a big event. I don't actually feel too bad when I have a big problem and I'm able to solve it. So there aren't any major questions at the end of this this section, but I do remember there was one thing that I was feeling a little uncertain on. So I think what I'll do, first of all, I'm going to get out of this chair and I'll probably like make another cup of tea and I don't know, douse myself in cold water or whatever, because it is still quite hot. It's almost 30 Celsius and the sun is now down, which is appalling. But I think, if nothing else, you, dear viewer, have earned yourself a break from me. So thank you very much for watching. We will definitely be moving on to part 9 for the next entry, but what I might do is a small review after taking a look at sort of what's happened inside here. If there was something that I was unclear on, a little bit like the mouse over, I'll start with that. I think that took about 15 minutes this time around here. So see you in the next one. Take care.